The topic is electron affinity and its periodicity. So electron affinity, it is a new topic to you, that what does mean by electron affinity. So by definition, electron affinity, it is the amount of energy released. It is the amount of energy released, and when this amount of energy is going to be released when we need to add on electron, when we need to add the electron in the valence shell of an isolated gaseous atom. Atom is in the gaseous form, and we need to add an electron in the valence shell of gaseous atom. As a result of this, the energy will be released. This released energy is known as electron affinity. Affinity mean to attract. So, how much the atom is having electron affinity for the added electron, this released energy is the measure of that process. So, when we need to add electron, for example, we have an atom B and we are going to add one electron in its outermost shell. When that electron is going to add up in the valence shell, amount of energy will be released. This energy is known as electron affinity. So the atom will be changes into the ion as -1 and plus the energy released. This is the real mean by the electron affinity. Affinity means to attract something, and the unit in which we can show the electron affinity, it is the kilojoule per mole. This is the unit in which we can measure the electron affinity. Next we have the examples related to the electron affinity. So for the chlorine, it is from group 7A. It is having 7 electron in its valence shell, and it needs one more electron to complete its octet. So by adding one electron in the valence shell of chlorine atom, we will get chlorine -1. Before the addition of the electron, its electronic configuration is 2, 8 and 7, and after that its electronic configuration will be 2, 8 and 8. Now the electron affinity E dot A is equal to -348.8 kilojoules per mole. This negative sign is showing that this process is exothermic. Exothermic mean in this process the energy will be released. So electron affinity or addition of an electron is a exothermic process. So we will show the value with the negative sign. Another example, for the oxygen, we have oxygen. We are going to add up one electron. So we will get oxygen -1. Before its electronic configuration is 2, 6. After the addition of one electron, now its electronic configuration will be 2, 7. But it, to get the stability, it needs 2, 8. So after the addition of one more electron, the oxygen will become oxygen -2, and now its electronic configuration will be 2, 8. And its electron affinity 1 is equal to first electron affinity is equal to -141.0 kilojoules per mole, and its second electron affinity is 844.0 kilojoule per mole. So this is the electron affinity of oxygen and chlorine atoms. Next we have trend of electron affinity along the periods. In the periods, when we move from left to right, left to right in the periodic table, as the electron affinity is going to increase. Why the electron affinity is going to increase in the periods? The reason is that when we move from left to right, for example, we have lithium, its first shell is having two electrons and the second shell is having one electron. After that, we have beryllium. In the beryllium, first shell is having 2 electrons and the second shell is having 2 electrons. After that, we have boron. Boron, first shell, 2 electrons. Third shell is having 3 electrons. Boron, after we have carbon. First shell is having 2 and the second shell is having total 4 electrons. Next we have after carbon we have nitrogen. Atomic number is 7 and the last shell is having 5 electrons. Then we have oxygen. First shell is having 2 electrons and the last shell is having total 6 electrons. And then we have fluorine. First shell is having 2 electrons and the second shell is having total 7 electrons. So when we move from left to right in the periodic table, there is an increase in nuclear charge. Nuclear charge is a charge on the nucleus, that is positive charge. When this charge is going to increase, the size of an atom is going to decrease. Size of an atom is going to decrease. Now, the valence electrons are going more closer to the nucleus. When the distance between the nucleus and the valence shell is going to decrease, then the affinity for the added electron, affinity for the added electron is going to increase. In turn, when we move from left to right, the electron affinity will be increases because the nuclear charge is going to increase. Now, this nuclear charge will pull the added electrons more forcefully towards itself. Next, we have the trend of electron affinity across the group. So, what is the trend of electron affinity across the group? When we move from top to bottom, we have the structure of atom like this. For example, the first one atom is we have hydrogen, 1 electron in the valence shell. The second we have lithium, it is having atomic number 3. Then we have sodium, first shell is having 2, second shell is having total 8 and the third one shell is having total 1 electron. Then we have potassium, the first shell is having 2 electrons, second shell is having 8 electrons in it. The third one shell is having again 8 electrons and the last one shell is having 1 electron. So when we move from top to bottom, the factors that are going to increase, it is the atomic size is going to increase. The valence shell is going away from the nucleus, is going away from the nucleus, or we can say that the distance between the nucleus and the valence electron is going to be increase. So the pull of the nucleus towards the added electron is going to be decrease. In turn, when we move from top to bottom, the electron affinity is going to be decrease. So electron affinity will be decreases when we move from top to bottom. So this is the simple trend of electron affinity across the period, across the group and along the periods. I hope you guys understand about the trend and the electron affinity along with the examples. And if you guys have any queries about this, you can ask me about in the comment section and I will get back to you guys soon, inshallah. For that time, have a good day and Allah Hafiz.